well fed, ready to talk about everyone's favorite developer pastime, debugging? No. All right, well, hopefully after this talk, you'll feel a little bit better about it. So just to kind of get started with who I am, I'm Cecelia Martinez. I am a developer advocate for AppFlow by Ionic. So if you've stopped by the booth this week, we've probably chatted. If you haven't stopped by the booth, come by this afternoon, grab a t-shirt, learn more about that. I am a local. I'm in Atlanta. We'll rep Atlanta, love this city. And I like to do a lot of community work in the tech community, especially for underrepresented people in tech. So I'm a member of the GitHub Stars program. I also am the chapter head for Atlanta Out in Tech. So we support the LGBTQIA+ community in tech. And I also am a volunteer with Women Who Code Front End, which is a global track not tied to any specific city or location, but for women who code in front end. So if you have any questions on those as well, feel free to say hi. And then you can also, you can find me on Twitter at Cecelia Creates, also on GitHub at Cecelia Creates, if you want to connect. But so, why am I talking to you about debugging today? So probably like most of you feel, I was not really ever good at debugging. This was basically me whenever I encountered something in my code that did not work. I did not know where to start, how to address the problem, and it ended up being a pretty painful experience. And so that's kind of, lead me to this next question, which is who here was actually taught how to debug? Raise your hand if somebody, either a teacher or somebody on your team, sat you down and was like, these are the steps that you need to take to debug a problem when you encounter that. Anybody here? Okay. Few very lucky people. So that was not me, and that was not the experience that I think most people have, where somebody actually said, this is how you debug. It's a very critical skill. So when you encounter a problem, you end up using what I like to call the debugging dartboard, where you just kind of like throw some things at the wall, see what sticks, kind of isolate yourself, like turn down the lights, put on the headphones, hope for the best, refresh your browser over and over and over and over again. And that's a lot of what I did too. A lot of trial and error, a lot of just really horrible experiences until the very end it was a semicolon missing or a typo or wrong function name. And so that's something that I've personally experienced, and I imagine a lot of you feel the same way. But who here has debugged in the last week? Who here has debugged like today? Or I guess we're at a conference, but a couple hands. All right, don't stop working, pay attention to the sessions. So developers, we actually spend, like up to half of our time debugging and maintaining software. Engineering managers talk about how developer teams feel more like mechanics, just like trying to keep the car running, versus architects actually building out new features and solutions for their users. And so we spend up to half of our time debugging, but we aren't really ever taught how to do it effectively. And that's what leads us to our problems. So debugging is very complex because our applications have gotten much more complex. If you think about, you have an application, like you're adding something to a cart, and you hit the Add to Cart button. What is happening in your application code when the time that hits, right? You have your event listener, maybe you update a front-end state management, fires off to the back end, checks the database, sends it back up. You have a loading spinner that maybe is there. And then if you're using a framework, it's even more complicated. You actually have to deal with things like, whoops, my slides there. Frameworks add even more complexity. So you have things like, let me just pause this here. Sorry about that. Nope. Yeah. 1 second. Auto advance. Got a little out of control here. Just turn that off. See, I should have debugged my slides before I started this talk. I tell you, it happens to all of us. So let's get back in there. So there's a lot of things that happen during our application, right? If you're using a framework, it gets even more complex. You have event emitters, your dispatching actions. You may have hooks that are waiting for something to update that will then refire. At any one of these steps, something can go wrong. So if you have an application, you click that add to cart button and nothing happens. There's not even an error in the console. You have no clue what went wrong at any one of these points. You may have to do debug every single one of these steps along the way. And then it turns out, like I said, it was a typo, or it was a weird line break, or whatever code you're using, right? And so that's the kind of experience that we've all been through, and we want to try to avoid by having a good approach to debugging. So I added this slide last minute because it was a really great tweet, and that's why everything kind of got messed up today. But this was a really great tweet by Julia Evans, who's actually working on a book about debugging strategies, and she has this really great graphic about a debugging manifesto. These slides are shared, so you can access them and access all the links. But a lot of the things that she's talking about here are echoed in what I'm going to talk about today, which is having a solid approach to debugging and doing it in a collaborative way with a process can make it better and help you identify patterns so that it becomes a much less painful experience. So another question here. What does your debugging process look like? Anyone feel free to raise your hand, shout it out. There's not too much of us here. But if you encounter a bug in your software, how do you start? What's your process?
Figuring out exactly why it's doing what it's doing.
Okay, can you be a little more specific with your first step, maybe?
Probably figuring out where it's happening.
Okay, like that. Yeah.
I would assume first, just from my and then I go to my console just to see if what I'm assuming is matching well.
Okay, so hypothesis and then testing the hypothesis, right? Okay. Back there in the green shirt.
Okay. I'll read it. If I don't have any idea, I'll copy and paste it and put it in Google.
Nice. Yeah.
Adding a few console log and looking until this point it's working and data are as I'm expecting, and I'm making a lot of console logs and looking because I need to find a point where it is stopped working as expected.
Okay. Red shirt in the back.
If it's from a user, if I can reproduce it myself.
Yep, reproducing. Yeah, that's a good one. Anybody else have anything else that they do differently? Miranda?
We use Sentry to log all our errors, so we have specific errors, and then it's easier to handle. But there's also the good old console log and reading comments and random occurring.
Sean?
Of course, I use to debug all my tests, so there's a nice little error that's right there that I can read, but that's the shameless plug.
Nice. All right. Anybody else do anything differently?
I'll look for the endpoint that I'm expecting to hit, or the code that I'm expecting to hit. I'll skim through it and see if it does roughly what I think it's going to do. And then I'll start the debugger and see if that actually gets hit. And slowly start setting it.
Nice.
A bunch of alerts.
All right, nice. Yeah, so obviously there's, all those were different answers, number one, I want to point out, right? So we all approach bugs differently. One does not look like the other, which is good. What's important is that you do have a process that you can approach intentionally. The other thing that I kind of wanted to point out that I heard is we heard things like console log, debugger, alerts, error messages, and those things are tools, not necessarily a process, right? So if you want to build a table, the process isn't hammer. The process is, building out the pieces and then putting them together. So really when you think about a process, it's a methodical approach, the methodology that you use to approach the problem. And so that's what I'm going to talk about today. I'm going to talk about what my process looks like. And again, everyone's process can be different. Find one that works for you and do it intentionally in a repeatable way so that you can have a better experience and start to identify those patterns as you're debugging. So I'm going to walk through this process. This is a process that I use, but it's also a process that I have found that a lot of developers use. So I am a community ambassador for a tool called Replay, which is a debugging tool. And as my work there, I talk to a lot of developers about their debugging processes to try and find commonalities in what worked well and what didn't work well. So these are some of the lessons that I've learned from those conversations. And the first step that a lot of people do is, we heard it, reproduce the issue, right? And so reproducing means to recreate the issue in a debugging environment. If you can't reproduce the bug, it kind of doesn't exist because there's no way you're going to be able to know what happened and be able to dig into it. How many of you have received like a bug report with just like a random screenshot or, hey, this isn't working, please fix. And so obviously with that, you don't have the context that you need to be able to debug it. So that's always going to be your first step, is to reproduce the issue. If you're in developer mode already, you just have to like restart your server and or trigger the functionality that caused it in the first time, and that's your reproduction right there, right? You can also, you may need to like pull down a certain version of the code base that a user is using. It may be in prod, it may be in your local environment. But essentially, you want to be able to recreate that same experience that triggers the bug in a place where you can use your debugging tools like breakpoints and console logs and error messages. So you can also use a tool like Replay, like I mentioned, which records, lets you record a bug, and it records everything that's happening in the browser. This is a video of a real bug in Cecelia, which is a kind of like drawing platform that you can make charts and graphs and everything, and it's an open source tool. And somebody had reported a bug where once you resize a shape down to 0, it locks up, and you can't resize it back up. You can see on the screen this video, it's kind of locking up and going into a straight line. So this is what a replay looks like. It's essentially a recreation of what happened that lets you play the video back, and then we'll also dig into the code as well. If you're interested, there is a blog post with more details about this specific bug, and you can click around and play in the replay too at tinyurl.com/Cecelia replay. But this is essentially what the bug is, and this is the reproduction. This is the recording of the bug. I was able to reproduce it and see what happened. Well, on the note too, I am not on the Cecelia team. I just kind of, we found this bug, wanted to try and reproduce it. It's an open source project, and dig into it. So I'd never been in the code base before, but wanted to take a look at the bug itself. So the next step that we would talk about is defining the problem. So like, what are we trying to fix? A lot of times we'll assume a solution or be like, oh yeah, I've seen that before. Or like, oh, that area, like, yep, it's such a mess. Or like, oh, I made a change there last week. That's probably what it is. Let me revert it, without actually knowing if that's going to solve the problem that we're trying to solve. So what are we trying to fix? And again, that doesn't mean to assume a solution, but rather to think about how does the bug deviate from expected behavior. This does require us to know what our application is supposed to do when it's working, which sometimes isn't always the case. Again, I hid my add to cart button and nothing happens. Was it supposed to show an alert, maybe, that the quantity was out of stock? Was it supposed to confirm that I wanted to add to cart? Was it supposed to show me a buy now instead of add to cart prompt? Like, if you don't know what it's actually expected behavior, it can be harder to define what's actually going wrong. So that's usually your first step, is to break out the expected behavior from what's actually happening, and that will help you understand what more tightly coupled to what the problem is. And so understanding what's expected helps us with kind of the next step, which is going to be isolating the issue. So isolating the issue means to narrow it down as much as possible to the area that you want to actually fix. Going back to that example with all the different event emitters and every single step that went along the way, you don't want to have to go through those one by one. There's kind of like this phone book example people may have heard with algorithms, and where you need to find a name in a phone book, and it starts with M. You don't want to start with A and go all the way through to M. You want to be able to isolate it down to a specific area of that phone book without having to read through every single name. Same thing with your code base. You don't want to have to read through every single line of code to figure out where the actual problem is. So we isolate the problem by inspecting, using inspecting tools. So some of the debugging tools that y'all mentioned are browser dev tools and framework dev tools. Framework dev tools are specific to whatever framework that you're using. There's Angular, React, and Vue dev tools. These allow you to inspect your components in your application at any given point in time to be able to see state, props, certain values in your components, as well as the component tree to be able to see the relationship between the components in your application. That can be more helpful sometimes than browser dev tools, which lets you inspect the actual HTML and CSS elements on your page. because sometimes the bugs are happening in how you've utilized the framework and not what actually gets compiled or what gets displayed in the JavaScript and HTML and CSS on your page. So these are going to be inspecting tools, again, that are involved with taking a closer look at whatever the current state is of the application that's being rendered. So let's take a look at that in action here. So this is, again, in the replay. So replay not only includes a reproduction of the bug, but it has debugging tools built in that you would see in browser or framework dev tools. So this is a screenshot of a replay, and we have React dev tools open. Has anyone here used React dev tools before to inspect components? Okay, great. So some hands here for sure. And again, I'm not familiar with this code base. I've never even still to this day, never pulled down the Excalibur code base and taken a look at it. This is all done within the replay itself. But I knew that this I went and I found the component. They're not named, but I found the component related to the canvas. And I started to take a look at the state that was associated with that specific component to just try and learn and see what was happening here. And I found that there was a resizing element property in my state for this component, for my canvas. And here I could see the width, I could see the X and the Y values, I could see that it was a rectangle, the height, and it had some values here for scroll X and scroll Y. And so, okay, there is some kind of state being managed to handle the resizing of this element, and that's where my bug is. So that's a good way for me to help to isolate this issue and narrow it down. So I started by using my inspecting tools in order to try and isolate the issue to where the problem could be. From there, I searched my code, and I knew that there was a resizing element state, and so I figured it must be my code somewhere. And I used a function search and then replay to find this resize single element file. And I took a look in there, and inside that file, I found a resize single element function. And within replay, I can see how many times each line of code was hit within the recording. So it does record all the code execution as well. And I was able to see that this function, resize single element, was hit 95 times. So that's probably my culprit, because as I was dragging it down, as I'm resizing it, this function is firing off and resizing it. So if there's something going wrong with the resize process, this is probably it. And so this is where I isolated down to, and I found this function as my potential culprit for the bug. That takes me to the next step, which is evaluate. So evaluating means to understand the execution of your code and also the values of your code at different points in time. So inspecting refers to taking a look at the actual application interface, your components, your HTML and your CSS, using tools like browser dev tools and framework dev tools. Evaluating is going to be taking a look at the actual execution of your code, so how it runs. Think of inspecting as how it looks, evaluating is how it runs, right? And our code doesn't always evaluate in the way that we think it's going to. It's going to do something. We have assumptions about that, but they're not always true, And so this is where we'll use tools like console logs, breakpoints, stepping back and forward throughout time, logging certain values to the console in order to see what they are when a function executes, in order to understand that. So here's a video. It's going to loop, so it's okay if you miss it the first time, of me adding a print statement. I'm sorry if it's very small in the back. So a print statement or a console log, they're both the same thing, to a line of code. So within my resize function, I found that there is a value called element new width. And I'm assuming that's the value that, as I resize down my square, it's getting to. So I decided to log that to the console. And so I'm able to use autocomplete, log that to the console, and replay will show me the value of that over time in the video and within the recording. And I scroll down, and eventually I realize that element new width starts to resolve to not a number, nan. So at this line here, you'll see the red line, nan. And every point after that in the recording, when it's stuck, element new width is nan. All right, we're getting closer. We're evaluating the value. We're seeing, okay, nan. So then I start to trace that up. And I'm saying, okay, if there's a problem with element new width, where does that get calculated from? And I can see that element new width is equal to element.width times scale x. And if you remember, there was those scale x and scale y properties in my React state. And so now I'm logging scale x, but I don't want to log all of it because there's like, it happens a lot. I really just care about when my element is getting down to like small, to 0, so I just do less than 4. So if it's less than 4, I go ahead and I log the value of scale x. And here I can see it's getting, the width is getting shorter. As it's getting closer to 0, scale x becomes negative infinity. And that's right before it hits nan. So there's already a problem before we even get to that element new width. And our problem is with scale x. So let's go deeper. We can go deeper. If my slides work, okay. And so here, I have a comment. I added a comment too. You can add comments in replay. So on line 451, we are dividing by bounds current width to calculate scale x. And I'm paused in time so I can hover over the value and see that at this point in time, bounds current width is 0. And so we all probably know if you divide by 0, math does not like that. Math gets very mad. And at the end of the day, a lot of code is math, unfortunately, in my opinion. But so what's happening here is after this point, once we divide by 0, scale x evaluates to negative infinity. Everything breaks down. It freezes up. So we went through the steps. First, we reproduced it. We had the recording. We defined the problem, which is that once it resizes down to 0, it freezes up. So that from there, we were able to isolate and focus in on that resizing functionality. We did that by inspecting our React component state, finding which parts were related to resizing, going into the code itself and finding that function, and then using evaluation with console logs and with our print statements, and being able to actually view those values over time to trace the problem up to what it always is either math or typos, like every time, right? Math or typos. And so that's the process that I use to solve this bug. And really, like, what ended up happening was we reported the bug to Excalidraw, and we had the replay. I added the comments and was like, this is the line that you have the issue in, and they fixed it the next day. It had been a stale bug for 2 months. And just because they had a reproduction and they had a comment to go with, somebody had already looked at it. And again, I am not an Excalidraw developer. I would say I'm not even a super senior developer. But by following that process and tracing it down, I was able to find the issue, and they were able to fix it. So that takes me to the last step, which is collaborate. How many people wait too long to ask for help when they're debugging? Okay, yeah, so I was the same way. I didn't want to look dumb or ask a dumb question or bug somebody. And so, you spend a lot of time just beating your head against a wall or you're doing the head desk, right? Because we wait too long to collaborate. And that's where you can leverage a lot of help. I added comments in the replay. I will also share that. It's a shareable URL, so I could share it with the Excalidraw team. I could also share it with people on my team and be like, hey, just gut check. Does this look right? Or do you think do you think it's a red herring? And get involved early with other people. Because the thing about code and debugging is that you can expand the knowledge that's available to you. There's a lot of things out there to know. We'll never know all of it, right? I don't know 1% of what there is to know out there. And so by collaborating, we can share knowledge and get to results faster because that's ultimately what we want to do. We want to get back to building. We don't want to be mechanics. We don't want to spend all this time tracing down problems. And so the earlier that you can collaborate and let people in on the problem, the faster you can get to a solution, and the faster that you can also learn. So I like to say that maybe the real treasure was the bugs we fixed along the way, because with every bug that we fix, we learn something new. And so this is a bug that we probably have seen before, or an error message, I should say. Type error, x is not a function. So who has seen this before in their JavaScript code? Yes, okay. And so really when you see errors and you have seen this before, you start to be able to identify patterns. So what are some of the reasons that this error could occur that y'all have seen? Feel free to shout them out. Never invoke the function. Yes, you actually add another one.
Maybe x is typed twice where you defined it and it's looking for xx.
Yep, something like that, yeah. Oh, sorry, go ahead, you first.
Sometimes the variable gets redeclared later in code.
Okay, redeclaring variables.
Sometimes the definition of the function is below where it's called.
Okay, yeah.
missing operator if you have x and parentheses and between you forget to it's typo, no operator is there, so it'll translate as a function call.
Okay, yeah. So we've seen this before, is what I'm hearing, and there's a lot of different ways that it could be. But these are patterns that we've seen. You know, these are some of the things that I came up with, just that I've personally experienced. So typo in function name, using the wrong prototype. So if I'm trying to call like an array prototype on a string or a string prototype on an array, and that's saying that it's not a function. Variable is the wrong type. Like I think it's supposed to be a string, but it's not. And I'm like, whoops. If I missed an import, if I'm trying to call a function from a library and I never actually imported that library, it won't be able to find that function. So these are all things that I've experienced because I've seen them before. So there's a really great talk by Jen Creighton, aka Girl Code, on Netflix, and she's a senior software engineer at Netflix. And she talks about debugging too. She talked about async debugging in JavaScript at Reactathon this year. You can watch it on YouTube. And I took a picture of the slide, so I thought it was great. And she also has blue hair. So, but the best debugging tool is knowing something well. You don't know something until you know it. And how many times, like I've used like libraries before where it's just like, oh yeah, there's a really weird quirk. And that's an async function, but everything else is sync. So if you use that one, you just have to remember that it's async and use it the right way. And so the more that we are able to expose ourselves to the knowledge of others, but then also to practice debugging, the more we're going to be able to learn to be able to identify some of those patterns. The same pattern that we saw with that type error, x is not a function. So some of the patterns that exist when we talk about debugging, we can talk about some of these. The first is component rendering. What triggers a render? So if you are a React developer, Vue, Angular, probably especially if you're a React developer and you're using hooks, understanding why components render when they do can cause a lot of bugs or a lot of issues. So lifecycle hooks, they have to be called synchronously instead of in Vue 3, for example. If you're using a use effect hook in React, it will only trigger if you pass, if you're waiting for a certain variable to change, if you pass that variable as an array as a second option. Did not know that, caused a bug. If you have components that render too many times, that can cause either performance issues. If you've seen them, like you hit the button once and it re-renders 30 times because it's going to re-render for every single value in an array, and really you just need it to re-render once at the end of that value, understanding what triggers those. And then another aspect of that too is when you think about state. If your components are rendered based on state, but then they don't update again the way that they're supposed to, then you could be showing stale data in your UI that doesn't relate to what's actually happening on your logic or your back end. So that is something that is a big cause of issues with bugs, especially if you're using frameworks. And how many of you here use frameworks for front-end development? All right. How many of you have experienced a bug? How many of you have been personally victimized by a bug because of a framework? Yes. And so understanding the intricacies of the framework that you're using can help you better identify those patterns. And a lot of that isn't going to come until you encounter those bugs or you get exposure to it, or if you want to just read the docs like crazy, which is always an option for sure. Another thing that you can do, though, is you can use those framework dev tools to understand the relationship between your application, your framework, and the code itself. So earlier I talked about, we looked at the React component inspector. There's also the React profiler, which allows you to record your application and then see component renders over time. So you can click on a button, you can see which components are being re-rendered and why they're being re-rendered. Same thing exists for Vue as well. And that allows you to understand the relationship between the component renders within framework or within React and why that's happening, and the code that actually triggers it. So that's a great way to debug if you are like, I swear this should be firing and it's not. Like, why is that happening? The logic and the JavaScript is correct, but it's just not interacting the same way. Use those framework developer tools. React specifically has a really great tutorial that walks through how to use it. Angular DevTools also has a great one, and the Vue DevTools doesn't have as much documentation, but it's super, super easy to use. So understanding what triggers a render is a big pattern. Another one is going to be state. So who here has used state management, like a state management tool or a store or a state management library, things like Redux, NGRX, RxJS, Vuex? Yeah, so again, a lot of intricacies get introduced when you're dealing with state. The things that we see a lot of times are multiple sources of truth. So if you're holding state in components, but then also holding state globally, those can compete. One of the very first bug that I fixed at Replay was related to having two different state controlling the toggle animation, one that was in the toggle animation component itself, and then one that was in global state, because that was changing the view and the actual application itself. And so that was something where if you triggered it from the toggle, it was fine. But if you triggered it from a keyboard shortcut, everything broke down because there was multiple sources of truth of that state. So that's a pattern that you'll see a lot, is if you have competing sources of truth, or if you're holding the same value of state in two different locations, that can definitely cause bugs. Another is accidental mutation. So I'm friends with Mark. I used to work with Mark Erickson, who is the Redux maintainer, or he's a core maintainer for Redux. And I asked him, what's the biggest bug that you see with Redux, with state management? And he shouted from the rooftops, accidental mutation. He was 100%, that's the most common. And so it's common in state, but we also can see it in other areas of our application, right? So whenever we change something, mutation means to change something that we don't mean to, whether it be by running a certain function on an array that returns a different value than we expect, or if we reassign something, anything that gets accidentally mutated can cause bugs as well. So those are some patterns to watch out for whenever you're trying to debug something in your state. There's also error handling. So errors are a gift. Like I said, when you hit that button and nothing happens, all right. If you hit that add to cart button and nothing happens and your console is beautiful and white, or I guess if you're using dark mode, if it's dark, and there's not a single line in there, no red, it makes me want to cry, as I'm like, no, please give me an error. Something must be wrong. And I checked the network requests, and there's no the function, the API call is good. Then you actually inspect the API call, and it has a status of 400, but the return object is error, and you're like, why? Why would you do that to me? So errors are a gift. Do not hide them. Do not override, create what's called silent errors, right? So where things don't work, but we don't know why, because we're not passing up the error the right way. So a lot of the frameworks that we have built-in conventions for error handling. So if you are moving from one to the other, or kind of going into it that's new, you may kind of try to do it yourself or override the natural error handling behavior. So understand what those conventions are, because it's going to make debugging a lot harder if you're not able to see that. I was actually able to, I had an API issue where it was coming back and the status was great, but then I actually had to go in and I had to inspect the response object, and it was an empty array. And there was no checking that it shouldn't be an empty array. There should be a value there, and there was no error handling for that case. And so then I had to go even further into the API and actually log out what was happening, and that's where I was able to find the logic error in the backend in the API. But there was no error handling for what type of response should be returned, and that caused a bug. So making sure that you have error handling for cases, if you're using TypeScript, that does a lot of it for you, because you're going to get those errors in when you're running the code locally before it actually gets to production. But again, do not hide the errors. They are a gift. Another pattern that you're going to see across all frameworks is async issues, right? Understanding different nuances and quirks if you're using promises versus async await versus callbacks. So for those, actually, I'd recommend back to that talk by Jen Creighton. That's all about async JavaScript and how to debug that. So understanding these patterns will make debugging a lot easier as you get to know them. But in order to understand them, you do have to debug. You have to learn, you have to collaborate, you have to work together. So I encourage you to embrace bugs intentionally and with a learning mindset. So instead of thinking of it as okay, it's not working, oh my God, it's gonna suck. I hate this. We can put on our little detective cap, and I used to read those Encyclopedia Brown books. I don't know if anybody else did. I might be showing my age a little bit there. where really it's like, okay, no matter what, I'm gonna come out of this and I'm gonna learn something. So every single bug I've ever fixed, unless it was a typo or a semicolon, I have learned something. And even the ones that were typos, I learned a bunch because I ended up going down a rabbit hole of reading docs to try and find my issue, and it turns out that that wasn't it. But every time that you're gonna debug, you are gonna learn something. So try to treat it that way. It's like, I'm about to learn something about my code that you can then actually use to make your code better. So every time that you find a bug, think about where other parts of your application could also have a similar bug. So if you do see accidental mutation and you think, you know what, like I've worked on this, I've used this same pattern in other areas of my code base, that may also be buggy. Or if you realize that you do have multiple sources of truth, or you identify a way to have a more efficient render, you can use that throughout your code base to improve your application and make it easier for the next developer who works in that area of your code base, and make it easier for yourself the next time that you encounter that. So, embrace bugs intentionally in order to address some of those systemic reasons that we have bugs in our code to make it better for you. So yeah, so happy debugging. Thanks so much for listening. Again, I am Cecelia Creates on Twitter and GitHub, and I am available for questions. We have about, looks like 5 minutes or so for questions, and I'll be available at the Ionic booth too if anybody wants to chat. So thank you. Yes?
How do we get access to this slide?
Oh yes, great question. Beautiful. Thank you for asking. So it's on the first slide here. And so it is just slides.com/Cecelia Martinez/painless debugging. Why would you do that? Okay. And you can get access to the slides, all the links in their work. You can check out the blog post with the Excalidraw example that goes into the debugging process there.